Hi, I am Yasar Arafath. I am here with another maths video for class 10 CBSE students. I welcome all of you to this video. Trigonometry. Today we will discuss some trigonometric ratios of some special angles or some specific angles. Okay, this is the table we are going to study now. Okay, and these values we want to study. If there is a question, what is tan 30? So we want to take it from memory. So we want to, no need to memorize this table, some ideas how to make these values. So that's what we will discuss now. It's our today's topic, trigonometric ratios of some specific angles. Okay, so first we will concentrate on this 30, 45 and 60 degrees. Then this 0 degree and 90 degree. Okay. Okay, look here, I have made a table here. We want to fill this. Okay, so we'll take two right triangles here. Very important, two right triangles. One is 45, 45, 90 degree angled triangle. One is 30, 60, 90 degree angled triangle. So first I take this 45, 45, 90 degree triangle. For 45, 45, 90 degree triangle, two sides will be equal, right? Okay, this looks like 45. Okay, so 45 degree here. Okay, so a triangle like this. Okay, how we can name this triangle? Not like ABC. This is right triangle and also isosceles, right? So we can say yes. Isosceles right triangle. Isosceles right triangle. Okay. So here two angles are 45 degree. From this right triangle, we can make this this column, 45 degree column. Okay. So sine, cos, tan, so sec and cot values we want to get. Okay. So for that, suppose this side is A unit. So we use algebra to generalize. So we have already made a small table with these values, but we want to generalize. I think that table is also same table, same values will come here. Okay, suppose I take A for one of the perpendicular side. In terms of A, can we write the other two sides? What will be the second side here, the perpendicular side? A, right? This is isosceles. For isosceles, the sides opposite to equal angles are equal. Then what will be the hypotenuse? Okay, so I think we can
using Pythagoras theorem.
Yes, using Pythagoras theorem we can write. So suppose we give name ABC to AC square is equal to what will come? This AB square plus BC square, that is A square plus A square. So that is AC square is equal to 2A square. So AC will be square root of 2A square. What is square root of 2A square? You split root.
A root 2.
A root 2. A root 2. We can write A root 2. Okay. A root 2. If you get a perpendicular side of a 45, 45, 90 degree angle triangle, you want to multiply that given side by root 2 to get the hypotenuse. In some other terms, you can say if you get one side of a square, suppose this is 5 centimeter, what will be the length of the diagonal of that square? No need to apply Pythagoras theorem, the same technique you apply. What will be the length of the diagonal of that square?
Here, root 50.
Okay, root 50, okay. Root 50 in short, simplified. So you look here, can you see a similar triangle here? 45, 45, 90 degree angle triangle, right? Okay, so here 5 will come, here in place of A, it is 5. So root 50, that is right.
5 root 2.
5 root 2, yes. Root 50 you can simplify to 5 root 2, right? So if you multiply the side length of a square by root 2, you will get the diagonal length. Okay, so this triangle is important because it is the half of a square. Okay, so this is fine. Okay, so using these sides, we can complete this table. Okay, so from this table, can you say, suppose we take this angle A. So both angles are same, no problem. If you take sine A or sine C, both will come same. Okay, so sine A, suppose sine 45, what will come?
BC by AC.
Okay, BC by AC is fine. So give the values in terms of A.
A by A root
A by
A by A
A
root
root
2.
2.
A by A root 2. I am filling this in the table. Okay, so we got sine 45 is equal to A by A root 2. Okay, I am writing this value here, A by A root 2, and here itself we can simplify this. A can be cancelled, right? So what will be?
1 by
1 by root 2.
Yes, 1 by root 2. 1 by root 2. Okay, then what will be cos A? Here cos 45.
A by A root
A
2.
A by A root 2.
A by A root 2, same, right? Same. Okay, so we'll get to 1 by root 2, same. Okay, then what will be tan A in this picture? Tan 45.
A by A.
A by A
What is A by A?
1.
1.
1. Okay, then what is cosec A? Cosec A.
Root
Root
2 by
2.
1.
You just
by
take
A.
the reciprocal of 1 by root 2, sin A. So that is root 2 by 1, that is simply root 2. Okay, or from the triangle, how we can write is cosec A is equal to hypotenuse divided by opposite side. Okay, so A root 2 by A. So A can be cancelled, so you will get root 2. Okay, so sec A, I think by taking the reciprocal cos A we can write. What will come?
Root
Root 2.
Root 2.
Root 2. Then what is cot A?
1.
1.
Cot A is equal to 1. That is the reciprocal of 1. Okay, in other terms, the adjacent side by opposite side will be A by A, that is equal to 1. Okay, so if you remember this triangle, A root 2. So I think little more we can simplify this. We can take the side length as in units. Suppose the first perpendicular side is 1 unit. Then second perpendicular side will be also 1, and this will be root 2. So you simply memorize this triangle, then you can form these 6 values if you have this triangle in your mind. 45, 45, 90 degree angle triangle with perpendicular sides 1 and hypotenuse root 2. Then looking at this triangle, you can write form these 6 ratios. Okay, so now we take a 30, 60 degree angle triangle. I shall draw a triangle here. Okay, triangle is like this. Here 60 degree, here 30 degree, here 90 degree. Okay, so I take this side. Suppose to avoid the fraction, I think better we can take this side as 2A. Otherwise, there will come more fractions when we take ratios. So I take this side length as 2A. So can you tell what will be the side opposite to 30 degree here, the smallest side?
What is those thing?
So I have taken the largest side, the hypotenuse of this triangle as 2A. Then in terms of A, can you tell what will be the length of the smallest side in this triangle? A, right. A, very good. Okay. A will come because, you know, if we draw a same triangle here, we will get an equilateral triangle, right? So you take a congruent triangle with the 30, 60, 90 angle triangle and keep it with this, you will get like this 30 and 60 here. This will form an equilateral triangle, okay, with side 2A, with one side 2A. You can see that these two are congruent, therefore the smallest side, the side opposite to 30 degrees will be equal. So if these two lengths are equal and total is 2A, then one length will be A. So this side opposite to 30 degrees A. Okay, so I clear these. Okay, I think no need this now. Okay, so I mark here A. So now we want the side opposite to 60 degree. So we can apply Pythagoras theorem. Okay, so we have already calculated this in one question to find the altitude of an equilateral triangle. Okay, that's okay. So we can do here Pythagoras theorem using Pythagoras theorem. Suppose this is x. So 2a square is equal to a square plus x square, right? So 4a square is equal to a square plus x square. So you take this a square to left. So 3a square will be x square. So what will be x root 3a square? What is root 3a square?
A root 3.
A root 3.
A root 3. Okay, a root 3 is the side opposite to 60 degrees. So I change this x here and I write in terms of a. This is a root 3. Okay, so in a triangle, in a right triangle with angles 30 degree, 60 degree, 90 degree, the side opposite to 30 degrees, suppose we take as a, then the hypotenuse will be 2a and the side opposite to 60 degree will be a root 3. Okay, and now we can form these two columns. We can fill this column, 30 degree column and 60 degree column. Okay, so looking at this triangle, we take a 30 degree first. So what will be sine 30 from this triangle? Sine 30.
A by 2A.
A by 2A.
by 2a, right? We know sine is opposite side by hypotenuse. So side opposite to 30 degree in this triangle is a by hypotenuse. Hypotenuse is 2a. So a by 2a. So simplify this, a by 2a.
1 by 2.
1 by 2, right? We can cancel a's. So 1 by 2. Okay. So from this triangle, can you say what is cos 30?
A root 3 by 2A.
Yes. A root 3 by 2a. So can you simplify this?
Root 3 by 2.
Root 3 by 2, correct? Okay. So next one is tan a from the, tan 30 from this triangle. Tan 30.
A by A root 3.
Yes. A by a root 3. So simplify
1 by root 3.
1 by root 3. Okay, 1 by root 3. Now what will be cosec a? Just to take the reciprocal of sine 30.
2.
2.
2. Okay. What will be sec a?
2 by root 3.
2 by root 3. What will be cot a?
Root 3.
Root 3. Okay. Then now we can form sine 60 from this triangle. Sine 60. How will come? Sine 60. A root 3 by 2a. A root 3 by 2a. How will come?
Root 3 by 2.
Root 3 by 2. Okay. Then next one, cos 60.
A by
A by 2A.
A by
A
2A.
by 2a. Simplifying, we'll get it.
1
1 by 2.
by 2.
Okay, 1 by 2. Then tan 60, tan 60. 3
A
by,
root 3
A
by
root 3
A.
by A.
yes. Okay, so this is root 3. Okay, now what is cosec 60? Cosec 60.
2 by
2
root
by
3.
root 3.
2 by root 3. What is sec 60?
2.
2.
2. What is cot 60? 1 by root 3. 1 by root 3, correct. Okay, so I hope it is clear. This table is clear. So if you get one side of any of these triangle using these ratios, we can find out the other sides. We will do some example after discussing the 0 degrees and 90 degrees also. Okay, so you just keep these triangles in your mind. So the second triangle, the ratio of sides we can write in simplest form. Suppose this is one unit opposite to 30 degrees of smallest side, then the hypotenuse will be its double, 2 will come. Now what will be the side opposite to 60 degree? What will come? Root 3 will come.
Root 3. Root 3.
Suppose for some example, suppose 5 comes here, 5 root 3 will come here, and 5's double 10 will come here. That's a ratio. In any triangle with a 30, 60, 90 degree angle, if you take the ratios of the side, you will get 1 is to root 3 is to 2. 1 is to root 3 is to 2. Okay, so the smallest side will be half of the hypotenuse and the middle side will be root 3. Root 3, the ratio. If you take the ratio, it will come like this. Okay. And for this 45, 45, 90 degree angle triangle, the ratio will be 1 is to 1 is to root 2. Because all triangles with 45 degrees and 90 degree as angles will be similar triangles, right? So the ratio of the sides will come same.
So as I told, you don't have to memorize all these values, these 6 into 3, 18 values, but you need to remember these two triangles with the sides in the simplest form 1 is to 1 is to root 2 and 1 is to root 3 is to 2. Then if you want to take any of the value in this table, you just remember the triangle in your mind and take corresponding ratio. Now, whether it is opposite side by adjacent side or adjacent side by hypotenuse or anything we need. So these two triangles, 45, 45, 90 degree angle triangle and 30, 60, 90 degree angle triangles are very important in mathematics because they are the halves of a square and an equilateral triangle. And that is why we keep these two triangles in our geometric box. You might have thought before why we keep these two triangles in our geometric box. That's because they are the halves of a square and an equilateral triangle, and they have a lot of applications in trigonometry and other branches of mathematics. The other angles, 0 degree and 90 degree angles, the other two specific angles we can discuss in the next video. Until then, bye.